Hello, everyone. Good morning. If you're not awake yet, we're going to wake you up, okay? Because I'm a fast speaker, and I'm very loud, and I'm very excited about this project. So my name is Danica. I am a developer advocate at Snowflake. I focus exclusively on open source technologies, and for me, that means Apache Iceberg and Apache Polaris, both of which we're going to see a little bit of today in this presentation, where we are building a ridiculous but very useful, I think so, IoT project. So if you've seen me at other conferences or even before at Devoxx, you've probably seen some of my other IoT projects, and you might be asking yourself, oh my gosh, do we really need another one? Always yes. The answer is always yes. And I have a good reason. So again, if you've seen any of my talks, or if you're just a reasonable person, you would say that there's always justification to build another IoT project. And I like to build out things that actually solve a problem that's in my life. Okay, and so for this one specifically, we've all experienced the joys of working from home, the highs, the lows. It's all wonderful. I still work from home a little bit, and so I take a lot of meetings. I also do a lot of recordings. I'm a developer advocate, and so when I'm doing those things, I need a distraction-free environment. But guess what? My boyfriend also lives in my home, and he will sometimes just walk into my office in the middle of recordings, in the middle of calls. And even though the door is shut, and I'm sure everybody has experienced just the frustration of that sort of situation. So I figure, all right, maybe I can build something that will actually help me solve this problem, all right? And why not throw as much open source at it as possible, yeah? So the high-level plan here is that I wanted a way to connect what was going on my computer, camera and recording usage and my Zoom meeting activity, right? Those are the two high-level things that I wanted. If I'm on a call or I'm recording something, I want to indicate to my boyfriend, do not come into my office, yeah? And so I wanted to connect what was going on my computer with some sort of indicator light. I like to be dramatic, so I figured it would be an on-air sign, right? And so ideally, I'm capturing this information from my computer in real time so that I can update that on-air sign as close to real time as possible. And there's a lot of different technologies that you can plug into this piece to make this connection, but I'm going to choose Apache Kafka. In a past life, I was a developer advocate for Kafka, and I still use it pretty regularly, so we're going to toss it in here as well. And so I'm going to feed these Zoom and camera events into Kafka, and then have a consumer then on the Raspberry Pi to consume those events and drive that sign that I'm going to build. All right, so again, we're going to use Kafka. I said there's a bunch of different technologies that you can toss into this. The benefit of using Kafka as opposed to other messaging systems is really you get the persistence of this data, more flexible. And while I don't really need to keep this particular event data in Kafka beyond powering this on-air sign, that doesn't mean that I shouldn't do something with that data later on. So having it persisted to Kafka gives me the flexibility to then offboard that data at some other point in time to play around with it. And so I'm going to actually do that. We're going to do a bit of stream processing, pull that data out of Kafka for a separate use case, and then we're going to write it down to Iceberg tables. So then we can do some more interesting analytics down the line. Okay, we'll get into each of these components throughout the course of this talk. But first things first, what you're probably here for is to hear the ridiculous thing that I built. Okay, so let's build something. And I also want to give you as many of these tools that you can, so you can actually go home and build this for yourself if you want to. And so if you, again, if you've seen some of the things that I've done before, maybe not. I haven't done too many IoT projects. I'm still pretty new to this in the last couple of years. And I think comparing this project to other ones that I've done, all things considered, this was a pretty simple one, okay? So first up, most important thing, you need a Raspberry Pi. As we get into the other components, technically you can use an Arduino to build this out. I'm not the right person to ask about that, all right? So that is left as an exercise to the reader. Next up, what we're actually going to use as the on-air sign itself, this is a 64 by 64 pixel LED matrix. It's a little bit rudimentary. I kind of like the look of it. And I also have a lot more flexibility. Instead of picking out some other more polished monitor, I liked the look of this one so that I can build out and print some 3D printed components and kind of customize it for myself. All right, so that's going to serve as the on-air sign. And then that's actually a lot of components to interface with on the Raspberry Pi. So we also need an RGP, a matrix hat, to actually sit between the Raspberry Pi and that matrix and actually power it. Okay. This list, not exhaustive. Again, if you've done any IoT projects, you know that there's always some cable that you forget. Always, and then you're waiting 2 weeks for it. Thankfully for this one, most of the connectors, the components actually were linked to on the LED matrix itself. So again, I factored that into, this is just a simple project because I didn't have to search too hard to find all the things that I needed for this. And I don't know what sort of suppliers you have available to you in EMEA, but we use Adafruit and DigiKey. Maybe you're familiar with some of those. But they have like full guides on what sort of components you're going to pull together for something like this, right? So yeah, pretty easy setup. This is all we're going to use. It's pretty much plug and play. I'm going to do some hand waving here because it's plug and play if you ignore the fact that you have to do some soldering. So I don't know, if you're going to get into IoT or if you already are in IoT, like you can't just be in IoT a little bit. You can't just like dabble. Like as soon as you do one, then you buy a soldering iron and you're like, all right, this is it. And so I did already have a soldering iron sitting around, so it was okay for me. I did try to avoid using the soldering iron for this, but there's just one critical step. You had to jump on the back, depending on the size of the matrix that you buy, because there's a bunch of different ones for your needs. And so yeah, so here's some proof that I actually did the thing. This is a very messy workstation. I'm sure there are other things going on. I'm so sorry. But this is right after I did the soldering, which is why the soldering iron's in the back. You can get a cheaper one. You don't have to get this one. And so yeah, so once I had everything soldered, plugged in, this looks a little fancy, that wonderful little square dancing around, right? It's actually animated. I should have taken a video. I did not program that myself. So the cool thing, again, if you've done any IoT projects, I have lost my mind a number of times. You finally plug everything together and you write some code and then it doesn't work and you're like, oh, does my code suck or did I just not solder it right? And then you spend like 3 hours debugging that. So it was super nice with this matrix. And there's actually a repository, a driver that you install. They shipped that with some really handy demos so that you just run that once and then cool, the colorful square showed up, so I knew it was okay. I didn't have to worry about it. And this meant that I could go ahead and install the thing, okay? And you're going to be really disappointed by this, right? Because this is an on-air sign that I want to use to indicate to people outside of my office not to come into my office. Well, I just renovated my house, and I am not ready to drill a bunch of holes in my hallway for this. I'll get there. I think it's going to happen in the next month or so, too. I just need to mourn the loss of my pretty wall. But for right now, it's in the background of my office on my bookshelf, which defeats the purpose. But we're going to get to why this is actually okay. All right. There is some hand waving here, but it does the thing, all right? So it is there until we figure out. I'm working very closely with my boyfriend to come to terms with where we're going to mount this thing out in the hallway. But yes, it does work. It's all plugged in. We're good. Cool. So now let's power the sign, okay? We know that the sign works, the demo ran. Now we need to go ahead and capture the events from my computer that we can then consume from through the Raspberry Pi and power that sign. So this means we're going to use Kafka. How many of you have used Kafka before? Okay, there's some of you who have not. So we're going to give you a quick review of this. So Kafka is a distributed event streaming platform. So events, in this case, the camera and Zoom meeting information, these are going to be produced to and stored in specific partitions of Kafka topics, which are just a data set. They're going to be ordered by their timestamps. And once they're stored in these topics, they can then be consumed by any number of downstream applications in a way that doesn't affect the other downstream applications, right? They can all consume at their own rate and do whatever they want with that data. So Kafka lets us build decoupled pub subsystems, but it also lets it build out systems that can take advantage of the fact that within a single data set, there might be multiple partitions in that Kafka topic, and we can parallelize the processing of the data from those multiple partitions. Okay? So it allows us to scale out our applications down the line. It's not just good for IoT, it's actually good for production systems. Okay? So it's a good skill to know if you're not already using Kafka. All right, so Kafka, it's a distributed system. You're going to have to run a Kafka cluster somewhere, which for an at-home thing, you're probably just not excited about. But for at-home use cases, do not fret. You can run a whole Kafka cluster just in Docker containers on your computer, or maybe you don't want to do that. You can run it on a couple Raspberry Pis. I have not done that. That's in my backlog. I would love to do that at some point. If you're a little more hands-off, you can use some service like Confluence, get a free trial there, run it on MSK, or just anywhere else. Yeah, so we're going to do a little hand waving here. I was currently using a free trial for my Kafka cluster. It gets you pretty far. Cool. So once you have your Kafka cluster running, now I could start thinking about actually capturing and creating, generating those events to our Kafka topic. So first up, we have the camera activity. So camera activity was pretty cool from my perspective, because not only do we want to know if the camera is on or off, I also want to know from an analytics standpoint what application on my computer is actually using the camera at that time, right? Sometimes I'm just doing recordings, and I want to know if that software is using it, or if I'm just using it through Zoom or Google Meet. So I want to be able to accommodate that in the schema for this data set. So we have the timestamp, when this status changed, the status, so on or off, and then the application ID that's running that. All right. And then we have the Zoom usage. And this is going to look like a very similar data set, but we're going to specifically call out for Zoom as opposed to other meeting software. I use Zoom for like 99% of my work calls, so I figure it's easy enough for me to just explicitly use Zoom. But I could actually extend this out to capture other recording software like Google Meet or Teams as well. But for now, it's just going to be Zoom. We have the timestamp of that status change. And again, are we in a meeting or not in a meeting? Okay. So for each of these data sets, I'm going to create Kafka topics with one partition each, easy enough to change down the line if I want to, set the retention time to be 1 week because I want to minimize the amount of data that I'm storing in that Kafka topic for too long. And again, flexibility to change that later on. So I know what my data is going to look like. I've created these Kafka topics, and now finally we can capture the data from the computer and write it there. So for the camera events, first of all, I actually had a lot of fun figuring out how to capture a camera event on my computer, especially since I have, we all have the built-in, like the FaceTime HD camera or whatever it's called. But I also, for actual recording, have an external camera. So I want to make sure that I'm able, this solution is flexible enough to capture any camera usage on my computer. And so in the end, I found out that I could leverage the built-in Mac OS log stream to monitor the camera activity. How many of you have heard of log stream? It's great. If you haven't used it before, all the Macs have a built-in unified logging system, and you can use log stream on the command line to actually just see that constant stream of events, and it has a predicate option so that you can filter for specific events that are being generated to this logging system. Okay. So I created a predicate. Hopefully this isn't too small. I found out that for the cameras, every time a camera is changed, and by changing that means it turns on and off as well, the phrase AV capture session did start running and did stop running. Those are somewhere in the logs. Okay. And so I used that with the predicate option to just filter for all of the logs where that's actually occurring. Okay? And so from there, great, I can execute that on the command line, but wonderful. Let's take that to a Python script. We're going to use subprocess and execute the log stream predicate command. And then from there, that's just going to be a long running one. So every time we hit a log line, it's just going to be pushed to me, and then I can extract the relevant information from those log lines, build up a Kafka message based on the schema that we created, and then produce it to Kafka. Cool. It's easy. Thank you, Mac. You did something for me. That's wonderful. Now for Zoom events. This is a little more complicated. So when we go back to this is very much event-driven, right? Every time my camera turns on or off, that is pushed to those logs, and I'm immediately getting that. Okay, so that's pushed to me. On the Zoom side of things, I couldn't find a very clean or elegant, either way, I couldn't find a clean way to capture the Zoom events. Okay, so there just weren't really events. Instead, it couldn't be pushed to me programmatically. So instead, I had to be a little proactive and actually fetch the current Zoom status, like am I in a meeting or not. And the way I went about this is kind of a hack, but hacks work, so that's fine. So basically, I found out that I could check how many ports Zoom currently had open, and that tells me if I'm in a meeting or not. It's a good enough proxy. I mean, it is. It's just exact. Wonderful. So similar to before, I could take this, run it through a sub-process, and extract this information. So if the result of that, OK, we have 0 ports open, that means even if Zoom is running, that means that we're not actively in a meeting. Okay? Because I don't know about you guys, but I always have Zoom running in the background. It's just there, draining my battery. If it's above 0, I think it's usually 7 is the number. I don't know why we need that many open, but we've got 7 ports open. We are in a meeting. Okay? So the annoying thing here is that these are not events, right? I have to fetch this information. And so to make it a little hand-wavy, like event-driven, I'm like fetching this every like 2 seconds. And then I can capture this status and push it into Kafka. I do want to note that even though I'm checking this like every 2 seconds or so, I'm only going to send the message, the event, to Kafka if the status changed from the last time that we captured it. Right? So only when we will go to on to, off to on and on to off is when I'm going to send that message to Kafka. Okay? So it works, and you can do this too. This next bit, not very glamorous, but you have to productionize it, right? Make this real. So those scripts that I wrote to actually capture that information from the cameras and Zoom status, those need to be long-living. And I don't want to log into my computer every time and have to run those scripts, because that just ruins the illusion of this being a finished product, right? So I had to figure out how to schedule a script. I've never done this on a Mac before. So yeah, it actually wasn't that bad. So you take whatever script you wrote, and in this case, I have a camera monitor.py, and I'm going to create a plist file that's going to point to that script. Plist is property list, by the way, if you haven't encountered that before. 2 things to note. You'll need to set the right permissions to make that script executable by someone else on the computer. You'll also need, if you have any relative paths within the script, so in my case I had config files and logging files, they need to be absolute paths. All right, so I had to rewrite all of that. But then within the plist, you'll see toward the bottom there, I specify, all right, we give it a name, a label, we point to that file, and then we specify keep alive. So as soon as my user is logged in on this computer, it's going to execute this script, and it's going to keep it alive regardless of what happens. Okay? And one thing to note, you need to take that plist file and it needs to be saved in the launch agents directory on the Mac. And then from there, you're going to use launch control to actually load that script, that plist file, and then start it the first time, right? Because I wasn't going to log out and log back in. Okay. So it's that simple. I'm going to do that also with the Zoom activity monitor. And then with those up and running, then I could start to see, it's just kind of like a hand-wavy dump of the data from the Kafka topic. But we're generating these events to Kafka. And they're just constantly being generated to Kafka. It's wonderful. So at this point, we have written a script. I'm constantly monitoring my computer for both the camera activity, the Zoom events. We're pushing those into Kafka. Now all we have to do is write a consumer to use that information to power the sign. And so I'm going to write yet another Python script to set up 2 Kafka consumers. I had one for each of the Zoom activity and camera activity topics. And so within each iteration of a while loop, I attempt to consume from each of those topics. Sometimes they're not all going to have events, right? I might just have Zoom on without my camera on, or I might be recording without Zoom running, and that's fine. So from each of these checks, I have here, this is the camera status consumer. So I'm going to attempt to pull from it. And then, yes, if the status is, it has started, the camera is on, then we're going to return that Boolean true. And then we kind of combine that with the Zoom activity as well and try to see, should the light be on given the state of both of these things? Okay. So again, we're combining both of these things. A missing code snippet from here is a bit of boilerplate code from the LED matrix. And there's a pretty extensive guide. I can link to some of to the actual item on Adafruit if anybody is curious. But within that boilerplate code, we're setting it up. We're preparing the monitor to actually display text. But then once I go ahead and check the Booleans, I can display, in this case, on air, or something else like hello world. Really original, I know. But it looks cool in the background of my office. And something to know, so like that's it. But something to know here is that this looks pretty easy once you figure it out. There's definitely a learning curve. Like, I haven't built too many UIs in my life, but I feel like how we take some of those things for granted, how easy it is. And so for this thing, like, you see these random numbers on like the draw text for displaying on and air. That's like, okay, the starting pixel, and just trying to align these things. And it was just so annoying. And they give you a bunch of fonts, but really the fonts are just variations on the same font. And so if you want anything different, great, you got to go pixel by pixel. But it's fun. It's programming. It's great. So here's what it looks like. It does the thing. It does the thing. Very basic. It gave me the vibe that I wanted out of an on-air sign, but there's always room to do more. But at the very basic level, it does the thing that I needed it to do. And once I get this mounted outside of my door, I am unstoppable. It's going to be great. So at this point, we have a working model, right? I'm collecting that camera, meeting information, sending it to Kafka. We're driving this sign. We've accomplished the basics. But can we do more? And the answer is always yes, OK? It's always yes. And with free open source technologies out there, why not throw more at it? We can have fun here. So here's a reminder of the original plan. As you know, we've done these bits. That's great. But we can make it more interesting. So again, sort of going back to Kafka, if you've dealt with Kafka before, Kafka's great for a lot of things, especially when we need to build an event-driven reactive system like we just did. But the reality is that when you think about the zoom and camera activity that I'm capturing, it's useless as stream data beyond a second or so, right? If that light doesn't turn on then, like, whatever. Like, I'll move on to the next meeting, and it's probably going to be fine, right? The time to live for each of those events is just, like, so low. But just because I don't need those events for streaming to drive that sign in that moment, it doesn't mean that we can't use it for something else. Okay, so we're going to take those events, we're going to offboard them to a different system that can help us aggregate that data long term and help us do some fun analytics, because all analytics are fun. So we're going to do this with Apache Iceberg and Flink and some other cool things. But you might be asking yourself, why are we bothering with analytics at all? I lured you in here with a fun IoT thing. That is a great question that I will answer with another question. How many of you use Google Calendar? Enough of you, okay? People who didn't raise your hands, you probably also still use it secretly, okay? So I really like, okay, for those of you who did raise your hands, I really like that fun, very stressful feature that they have that you might not have even looked at, called Time Insights. It's a love-hate relationship for me. So Time Insights, if you actually look at, it's hidden in one corner of Google Calendar. It's cool. Sad. It shows you how many hours you spend in meetings. It gives you a cool breakdown of the types of meetings that you're in, like how many people are in it. And it shows an aggregate over different time periods. So I just love the trend here. Like, I am not okay. It just keeps getting worse. Like, how many hours in a week? It shouldn't be that high. Anyway, 59.3 hours in meetings in March. That's sad. Anyway, I don't know. I have no idea. I haven't looked at these and validated this, but it gives this to me. But yeah, so we can recreate this, right? I'm already capturing the time spent on calls, right? I have when I start a Zoom meeting, when I end a Zoom meeting. So I can more or less recreate this for myself, because why wouldn't I? And as a bonus, because I have that camera data as well, when the cameras turn on and off, I can also incorporate an additional dimension here. I can figure out when I'm just recording content. And also I can make assumptions based on like how often I'm in Zoom calls without my camera on, and see like it's probably within the first 2 hours of when my meetings start, because like no one's awake at that time and who wants to have their camera on. So I'm really excited to see that breakdown, okay? So cool, why don't we do this? We're going to offboard our Kafka data to do analysis like this down the line, okay? And so as we kind of saw in the plan, the diagram, Iceberg is great for this. We're going to take a look at what it is. How many of you have heard of Iceberg? How many of you have heard of it because of me? OK, great. All right, for the rest of you. All right, so Apache Iceberg is an open table format. It was purpose-built to handle large-scale data sets in a data lake. I want to nip this in the bud. It is not a database in and of itself. It is a specification on how you should organize the files in your object storage to better coordinate data that you're going to toss into your data lake anyway. So it does this by adding an extra layer of metadata. And then it just sort of coordinates and tracks those, the data files. We get a lot of cool features out of it. So when you think about it, Apache Iceberg is kind of the love child of a data lake and a data warehouse because it optimizes for the things that we like about both of those. So on the data warehouse side, we get governance. We get like a tabular, like a table structure. We get like a single source of truth. And on the data lake side, we get a lot more flexibility in the type of data that we can store, the formatting of it. We can handle unstructured and semi-structured data, and we have more flexibility generally in a data lake to bring whatever tools we want to kind of work with that data. So Iceberg allows us to combine all those good things and reduce some of the things that we didn't like about either of those. And it's a really useful thing. And so to really drive this home, Iceberg is great, I think, as an add-on to your real-time architecture because it gives you, in most cases, a cheaper way to sort of maintain that data long-term when it's no longer useful as streaming data. And so you can do fast and more efficient analytics on top of that information in the long term. All right. And so as a quick aside, this is how Iceberg does or what it actually does. So Iceberg is effectively just this metadata layer here, right? It defines a specification for how we actually create these files, our manifest lists, our metadata files. And so these are created every time, in most cases, every time you make an update to your table and provide new snapshots on your table. So you're able to go back and do like time travel and query the table from a previous state. But the really cool thing about Iceberg, I think, is that because it's an open table format, it's really championing interoperability, right? Anybody can come along and build out an Iceberg-compatible compute engine that can then interact with Iceberg tables. So ultimately, you're not tied to any one like vendor or any technology. You're free to like bring whatever tool you need to Iceberg to actually do what you need to do, right? So in looking at this, great, we've got our metadata, we've got our data. There's one thing that we do definitely need when we're dealing with Iceberg, and that is a catalog over here. So this is sort of external to everything else. And so the catalog helps to make it feel a little bit more like a database. It helps us track our individual tables, maintains a reference to that latest metadata file so that we can actually interact with that table. There's a lot of different catalog implementations out there, but to throw more open source at this, we're going to use an open source catalog called Apache Polaris, and that's its cute little logo. Okay. I spoke a little bit about sort of the Iceberg compute engines and interoperability, and to kind of prove it to a degree, here's a couple of the compute engines. This is by no means an exhaustive list. So we have on the left here the built-in ones that the Iceberg project ships with. So we have Flink and Spark. Then, of course, there's a bunch of other technologies and vendors that offer an Iceberg-compatible engine. Right? So by offboarding the data to Iceberg, it means that I can use any of these whenever I want, which is pretty cool. All right, so hopefully we're all convinced that Iceberg is the best thing ever. Talk to me afterwards if you're not sold on it. But the next step here is OK, we have our data in Kafka. We want to do analytics on top of this data, so we need to offboard it to Iceberg. And if you saw my talk yesterday, my very, very fast talk, I see a couple familiar faces. But you know that there are a few technologies that you can use to move your data from Kafka to Iceberg. Among a few of them is Spark, Flink, and Kafka Connect. But we are going to use Flink. How many of you have heard of Flink before? How many of you use it? OK, no one. Wow. OK, just someone maybe. So Flink, pretty straightforward, kind of. It's not really. Distributed processing framework. It is flexible to do both batch processing and streaming, but it's really, really good at handling Kafka data. I think it's the Kafka source and sync for Flink are the most popular ones for the project. That's why I wanted to use it here, since we're moving the data out of Kafka. It also has a lot of flexibility in that it has different layers of APIs that you can use depending on your particular needs and use cases. sources. But in this case, we are going to use FlinkSQL. So this is just one of the APIs available to us. And we're going to use this to both read the data from Kafka and write that data to Iceberg. And this is kind of the simplest way to get started with Flink, I'd say. All right? So reading from our camera activity topic in Kafka, this is as simple as creating a table with a Kafka source. You do that with the connector property that you see here on line 8. So connector equals Kafka. Cool. Done. We then refer to the specific topic that we want to consume from and pull into this table. That is on line 9, so we have the topic camera activity. And then from there are a number of configurations that we need for any Kafka consumer. So you need a group ID, our brokers, schema registry, way to connect with that, and a couple more in there, but that's all sort of boilerplate configurations that you'll put in there. So from there, looking at the top with the create table statement, we can define the table much like we would any other table in SQL, right? We specify the fields, we specify their types. One other thing that I want to point out here is that I'm also, as we're bringing in these fields, I'm also evaluating an expression as that data is coming in. So on line 6, you see here that I am actually extracting a piece of the camera timestamp as the what I'm going to use to partition the data on, the partition timestamp. So here I wanted to basically just look at the day of the timestamp. So like March 28th, we're going to take that and use that as the partitioning timestamp. All right. So I think that's pretty cool that you have the flexibility to kind of extract that as that comes in here. And in the Iceberg realm, being able to partition your data is actually very useful. So I just wanted to call that out as well. All right. And we are going to do a very similar thing on the Zoom activity topic as well. So just doing the create table, pulling in all that data, evaluating that expression for the partition timestamp. Only real difference here is pointing to that Zoom activity topic instead. All right, so at that point, after executing that, within FlinkSQL, we have consumers that are pulling that data from Kafka and are updating that table within FlinkSQL. All right, so that's there and ready for us to use. But now we have to prepare Flink to connect with S3, where I want to actually write my Iceberg tables, and we can move on with our lives. And so that starts with defining, and in this case, connecting to a catalog. When I went over that architecture diagram of Iceberg, I said that the catalog is really, really important to helping us actually interact with our Iceberg files. It's that first point that you actually hit, so you know which metadata file you're actually looking at with the most up-to-date version of that table. Okay, so you can't work with Iceberg unless you have some sort of catalog to use. Okay. Ultimately, they help to define, maintain our asset guarantees for our Iceberg tables, and just gives us some sort of semblance of organization and coordination there in our data lake. So outside of the FlinkSQL client, I'm running Polaris. Actually, as of last week, or maybe even this week, in the latest version of Apache Polaris, the community launched a super easy quick start that you can get started with Polaris and point to an S3 bucket, and actually on any cloud provider. So I'm just running it on AWS right now. Right, so once you have Polaris running, you create a catalog. It really takes care of all the governance for you. So I've created a number of roles and privileges that I've assigned to myself as the only user of this catalog. And along with that, I've created some credentials that I can use to identify myself as the only user of this catalog. So by running this statement then on FlinkSQL, I'm giving Flink access to that catalog. I'm allowing myself to create tables within that Polaris catalog, Iceberg tables. Okay, and this screenshot is actually old because it still points to localhost when I was running it on my computer. But rest assured, it runs elsewhere now. So from there, we need to create the camera activity and Zoom activity tables within the Polaris catalog. And note here, all right, so we are creating the table now within sort of the Polaris realm of the FlinkSQL client. So that's kind of separated out. We're specifying that catalog. So within Polaris, we're creating the on-air camera activity and Polaris on-air Zoom activity. And we're just going to use the same fields that we had from the tables that we were pulling in from the Kafka topic, basically just copying that over. A couple minor differences just in how you create tables, Iceberg tables. Specifically, partitions are important. They're going to help us to actually query the data a lot more effectively later on. So I'm partitioning by that partition timestamp. timestamp. And I'm also specifying the format version at the end, which is table version 2, which is just kind of the latest table version for Iceberg. Okay? So that's on the left. And then on the right, we want to insert the data into those tables that we just created. So this is just, all right, cool, select everything from our camera activity that we brought in our default catalog, right? And then we're going to insert it into the Polaris on-air catalog that we created. Okay, and we're going to do that for both the camera activity and the zoom activity. Okay. And so these screenshots, these were just kind of like one instance of actually launching the FlinkSQL client and running this. But you can imagine that this is a scheduled task that we have executing every couple days or at the end of the week or something to actually take all this data and push it into Iceberg for us. All right, so at the end of this, and this is an out-of-date screenshot, but cool. All right, the data is then pushed into S3. Within these sort of partition directories, it's then stored in Parquet files within each of those. And this is, I know it doesn't look too glamorous, but this is an Iceberg table. This is it. Okay, so it coordinates that data within those Parquet files in our data lake for us. All right. So, man, I did speak a lot faster than I usually do. That's crazy. I know this isn't a very glamorous way to end because there's a lot more that can be done, and that's exactly what I want to talk to you guys about. I want to leave you all wanting more so that you can take this further and hopefully build something cool like this. So now that the data is in Iceberg, yes, it is there, we can now use, as I said, any Iceberg-compatible compute engine that, to our heart's desire, and do whatever we want with this data. And I don't know if you noticed, but I built this a couple weeks ago. So at that point, I only had this much data in there. It's only been a couple weeks, and I took a lot of PTO in there. So haven't had too many meetings to actually push useful data into this data set. So I haven't done too much analysis on this data, which is why I want to focus on some of the cool next steps that I'm going to be doing here, so that I can show you just how excited I am to keep this going. So here's a bit of my backlog, and I'm always open to fun suggestions, where I can actually take this project in the future. So I haven't actually scheduled this yet, but I have determined that I am going to extract the data from Kafka at the end of every week. So I'm working to actually schedule that FlinkSQL task to be running once a week so that I can then just jump that into Iceberg automatically without thinking about it. Because again, I want to productionize this, and I really don't want to do any manual steps if I can help it at this point. So from there, once we have this scheduled, right now I'm just manually doing that and pushing it into Iceberg. But then I really want to get serious about analyzing my meeting trends and effectively building up that time insights that we saw. Up until I can actually find the exact way that I want to be analyzing this data, this is going to be sort of one-off analysis, just kind of playing the data and digging around. But I can envision sending out, say, like a push notification to make me very sad at the end of the week and tell me how many hours I spent in meetings or how long I spent actually recording things. But the cool thing is, in this whole section, is that I have the flexibility, as I said, to play around with as many of the compute engines as I want with that same data and just see what works best with my data set. So I also want to do a little bit more pre-processing, rely on Flink a little bit more for what it's good at, which is stream processing, right? And so I want to take the zoom and camera activity data and align those two topics so I can specifically call out when I'm on a Zoom call with my camera on or off, and when I'm just looking at, recording something without Zoom as well. So I want to be able to explicitly call that out. And I've been playing around with a query to make that happen, but that's something that I'm actively working on. And then within a query engine or a compute engine, I can compute the intervals and actually figure out how long I'm spending on calls or recording tasks. Okay. So those are the very basic things that I'm doing right now, but I know you want to hear about the stretch goals and how we're actually going to make the fact that the camera, that the on-air sign is not outside of my door actually makes sense, okay? So when we are both, when my boyfriend and I are both working from home, his workspace is all the way on the other side of the house in the garage. And I know that's a weird thing to say in Europe, but we have a very long house, okay? So there's a garage, and then my office is all the way over here, and that's just a far walk. That's a far walk. And even if I had the sign outside of my door, that's like, is he gonna even bother? And so what I want to do is I want to create a chat bot so that he can ask it if I'm busy right now, like if I should be bothered or not, basically. And that way he doesn't have to walk all the way down the hallway to actually see if the light is on or not. So that's like an easy thing that I can do to kind of give a proxy for the on-air sign without actually physically mounting it to the door, which is what, I'm pretty excited for that. And then finally, sometimes I just want to say when I'm busy. Sometimes I don't have to be on a Zoom call or recording something to say that I'm busy and I don't want to be bothered, right? So maybe that's like focus time when you're blocking off your calendar, or maybe I'm taking a call on my phone, or I'm recording something on my phone maybe. So I'm thinking to 3D print sort of a housing and have a couple just buttons sitting on my desk so that I can say, all right, we're doing focus time now, turn on the light, I'm busy. I'm on a call, turn on the light, I'm busy. And just have a couple more options to throw into the data set as well. And those will be broken out by the application that's like driving that light as well. So yeah, I'm really excited to kind of extend the on-air sign to use cases beyond what's on my computer. So that's something, hopefully by the end of the year, I'll get that all pulled together. And so yes, I hope that gets you kind of excited for things that are to come. I'll be putting out a blog post on this probably when I formalize a couple of the earlier things as well. And so I hope you'll follow along to see what other cool things we do with the project. And so I know I'm kind of running low on time by now, but I want to bring us back home. I know you were here for an interesting use case, and hopefully you are pleased with the use case we went through. So I want to remind you of sort of the original plan. So what I set out to do was to create a real-time pipeline that connects events on my computer to my Raspberry Pi, driving that on-air sign. We then use a separate workflow to extract that data with a couple of different open source technologies, so that we can then do some analytics with Flink and Iceberg and so on. Okay, and I think this is a pretty cool use case. I didn't just pull this out of the ether and decide to build this. When you actually look at these technologies grouped together, this is actually a very, very useful workflow and pipeline for people to be aware of. This isn't just something that you'll do at home for yourself. You can actually take this and productionalize it and actually take it to real world use cases beyond your home. So I built this whole workflow to be as robust and useful and real as possible. So with Kafka in there, you can easily scale out to more producers, more consumers, power different event-driven use cases at production capacity pretty easily. So even if you and say your company are like already looking into Kafka, you're already leaning into that for real time, you're always going to have other analytics use cases. Like, it's not all Kafka all the time. It hurts me to say that, but it's not all Kafka all the time. And so the ability to extract that data using some other stream processing, extract it from Kafka, and push that to a longer living system like Iceberg, that's a very real use case and something I'm seeing a lot of people do today. Okay, so while I hope you enjoyed this session, you enjoyed this story of using this project to build out a cool project for myself at home, I hope that you'll take this and also apply it to your own work, either personally or professionally, and maybe you'll consider using Kafka, Flink, Iceberg, and Polaris at some point in the future. And so with that, I want to thank you all for coming on my very quick, very chaotic journey of this project with me. I think I have time for a couple questions, and I also want to let everybody know that I have stickers for each and every one of these technologies, okay? So if you want to make the entire diagram on your water bottle or your laptop, you can. And so I have stickers up front for any of you who are interested. Before we get into questions, I want to leave you with my link tree. On there, I'm constantly updating this with new resources from across all of these open source technologies. The latest resource on there is that a couple weeks ago, we had Iceberg Summit, and all of the recordings are now on YouTube. So if you're curious to learn more about Iceberg, I would encourage you to check out that link. And so with that, thank you all. I appreciate it. And do we have any questions? Yeah. Oh man, with cats and dogs. But that's fun. People love when pets interrupt your call. No one likes to see like a significant other walk around. They're just like, oh, Why is there a person there? I think pets are fun to have in Zoom backgrounds. I have I don't have a pet. The only thing I have houseplants, which many of you have probably heard of, and I have a robot vacuum, and that's all I've got. Yeah, I'm so sorry. But I'll have a think on that. Yeah. Oh yeah, distract the cat. It tosses a treat elsewhere. Look at this, group problem solving. This is wonderful. Anyone else? Question?
I was at a Snowflake event when they talked about Iceberg, introducing it, and I noticed that you've almost got absolutely no Snowflake in this tool. How do you get away with it? You say you could read Iceberg files.
Yeah.
That's okay.
So you're asking how I got away with giving this talk?
Yeah.
I just come to the community. I'm here for the community, man. No, we were at a meetup earlier in the week in London, actually hosted by at the Snowflake office. It was a Kafka meetup, and because I have Kafka and Iceberg things. And someone was giving a talk, someone from New Relic was giving a talk on OpenTelemetry, and she was like, all right, and now we're going to talk about how New Relic fits into this because they pay my bills. And so that's sort of the reality of working in open source and also being employed by a vendor. I am a big fan of leading with open source and then just showing how, or just letting people know that who I work for and the product that we offer is just one part of the solution, right? So if you're actually following this workflow and you end up building something like this in your own, adding it to your own architecture in your company, you know that, okay, Snowflake is one of those options that if you're storing stuff in Iceberg, you have the flexibility to use it as well. And so if that's all you take away from this, then I am happy. So. That's how I get away with it. Anyone else? And I also have Snowflake stickers up there, in case you were wondering. Cool. Well, thank you all for coming. I'll be around and happy. I'll be at the Snowflake booth if anybody has any more questions. Thank you.